All right, so let's go ahead and talk about the paper I just passed out. We're gonna take a few, or go over a couple examples, really. We did some notes on Friday. Again, if you get a chance, that was the only assignment for Friday was still looking at chart, so that was Friday. But examples now, using circles. So in a circle, how many degrees are in a circle? 360. So again, in a circle, there are 360 degrees. Now, the first two problems are using the idea that there's 360 degrees and solving for x. So we have those two missing values. It's the only one of those angles that's missing. So we know that all of them should add up to 360. So if we subtract the ones that we have from 360, we should know what x is. So first, add them all up. We have 115. Try to start off easy and then make it harder. So add them all up. So we got 0, carry a 1. That's 8, that's 2. So we got 280 degrees so far. So 360 minus 280 is just 80. Yeah, I should throw a 1 in front of it for a second. It's just 80. That'd be our answer for x. On number 2, same idea. We got a 90-degree angle. All right, they didn't say 90, but they gave the right angle symbol. We got 90, we got 120. Add them together. So 90 and 120 is that's going to be 210. So then we have 360 minus 210. Gives us a total of 150. This is the plus. Yeah, that was plus. That's minus. Hold on. All right, in the bottom part's asking for both a arc measure and they want to know whether it is a minor arc, a major arc, or a semicircle. So first, a minor arc is any arc that is between what's the values? 0 and 180. A major arc then is anything between 180 and 360, and a semicircle is exactly 180, half of the circle. So on here, they gave us the one was 44. Now we're going to use some old properties to figure some of these angles out first. So that's 44. We should know the one across them is also 44. What type of angles are those? Okay, they are congruent, but there's a name for them when they're crossing each other like that. Vertical. Vertical is the one. So when you have two lines intersecting, the angles across each other are what we call vertical angles. So the vertical, they're both 44. Average of 94. Now, if those are 44, the arcs that they're intercepting are also 44. So A is 44 degrees, CB is 44 degrees. Now, these are diameters. So they're splitting a circle in half. You know that half a circle is 180. If I take 180 and subtract off 44, what's this other piece going to be? 1 minus 44. 136. So both of those are 136. Yeah, I could also put that on those inside angles if I wanted to, because again, the central angles and the arcs that intercept are all going to be the same measure. But now we have all the measurements we need. So let's go. So since, say, BE, for example, is a diameter. So this entire side will be a semicircle, which is a total of 180. So then I subtract it off 44. So 180 minus 44, and that's what KB would be. All right, so now we have all the measures we need. We just need to, there they are. Now notice, when they ask for the measures, they put that M in front. It's just like our notation when we use angles, right? So if we were asking for the measure of an angle, they throw the M in front so that we know that we're finding a degree. Same thing here, we're finding a degree, so they put the M in front. So the measure of arc BA, well, we already found that. That's 44 degrees. Now, they also wanted to say, is it minor, major, or semicircle? Well, it's between 0 and 180, so it's minor. All right, BC. What is BC? 136. I already found that. Good. And it's between 0 and 180, so it's minor. All right. Then we had CD. CD is again 44. Also minor. And now we have number 6. Number 6 is asking for measure of arc ACB. So they use 3 letters. Now, when I use 3 letters, that usually means one of 2 things. No, not necessarily. So if I use 3 letters, it's going to be either a major arc or a semicircle. So look at ACB. I'm going from A through C and around to B. So that means I must be going around this way. Going from A through C and around to B. So this is whole thing except for that little top piece. So I could either add all 3 of these together, or kind of like what we did on the first one, I could say, well, the whole circle is 360. I just need to leave off the 44. So 360 minus 44 leaves us with 316. Again, you can do that either way. Either add all 3 of these up, or just subtract that one little piece from 360. Either way, you should get 316. Now, is that a minor arc or a major arc? That's definitely major.
Wait, so if you just take
Yeah, I was going all around this way, from A through C and around to B. So that's this whole arc here.
then you just down into the
Yeah, so easiest way to find that one would be 360 minus 44. Again, we could have also added all 3 of those up. They both give us the same answer. All right, so now BCD. That is a semicircle, which is exactly and then finally AD, we're back to only using 2 letters. So this must be a minor arc. And looking at AD, that is how many degrees? 136. So we got 136, and again, that's minor. Any questions on that first part? Here, yeah, that's 136. Other question. That's not bad, but we have plenty of time.
Oh, 54.
I won't take too much of your time. You have lots of time to work with. I think every class I did like 15 to 20 minutes for work. So plenty of time. Okay, any questions here? All right, let's move on to the next side. So you have on the other half of your sheet, on your sheet it's not on those sides. Not those. All right. So now on here, they have an equation. That was my point a little too high. Equation was, right? So we have arc length. So when we talk about arc length or the length of an arc, we're still talking about a distance. So now we're talking about a distance on an arc. So the other day we did circumference form. circumference is distance around a circle. Arc length is gonna be part of that circumference. So, but it's just a little piece of the arc of the circle, not the entire circle. So how do we find it? Well, if you look at the equation that they have, this part is a fraction of a circle. Now, they use X because that's what they label the figure with over there. A lot of times, what I'll do with this equation is I'll put M on top because it's the measure of either the angle or the arc that we're looking at out of 360. So it's a fraction of the circle that we're using. The second part of this formula, 2 pi r, what's that represent? What's 2 pi r? What is it? Did this the other day. 2 pi r is the entire circle. What do you mean by the entire circle? Circumference, yeah. So this piece is our circumference. So really all we're doing is taking the fraction of the circle that we're looking at and multiplying it by the circumference. Now they give you this formula on that sheet, and most textbooks just use that formula all the time. But I wrote it on the board over here as well as 3 separate formulas. I just look at it as a middle form. You can do it either way, whether you plug in the circumference formula for a radius, 2 pi r, or you plug in the circumference formula using diameter, which is diameter times pi. Because a lot of times they're not going to give you the radius, they're going to give you the diameter. And then what you're going to do, divide by 2 and just multiply by 2 again. That doesn't make a whole lot of sense. Again, it's just the circumference, so you can use either of those formulas. All right? Don't make yourself do extra work. There's even times where they might give you the circumference and say, what's the arc length of this piece? Well, then I'm not going to go back and try and find the radius or diameter and then plug back into this. I'm just going to take the circumference that you gave me and multiply by whatever fraction it is. So on here, they gave us, for the first example, 135 for the arc that we're looking at for AB. They said that the radius is 8. And then they just plug into the formula, and that's it. And then they simplify. And in this case, they actually asked us to round. And on all the questions on this paper, they're asking us to round. So we're just plugging into a calculator. Now, when I do the first few examples down here, I'm going to do these first 4 examples with you guys. I'm going to simplify, all right? Even though it says fraction of 100, because could you have a question where it asks you to leave this as an exact value? Yes. Okay. You should be comfortable with simplifying them so that you know how to leave it as an exact value. For these problems and the ones that I'm going to sign on the back, I think most of them say round to nearest 100. So you're going to be able to plug them in the calculator today. All right, but any questions before we go and do these examples? So on here we have DE. Let's see, DE is right here. There's DE. We want that arc length. Well, they gave us the radius is 2 meters. They told us that that piece has a measure of 120. So plugging into our formula, we have 120 out of 360 times, since we're using a radius, I'm going to use 2 pi r. So we're going to do 2 pi r for our circumference, and that radius is actually 2, so I'm going to plug 2 in for the radius. So that's 2 pi 2. Now, I said I'm going to show simplifying this as well. 120 out of 360, it helps to know your fractions a little bit when it comes to a circle, but 120 out of 360 reduces all the way down to what? What is 120 out of 360? So that is exactly 1/3. Now, 2 times 2, that's 4. So I have 1/3 times 4 times 5. 1/3 times 4, that can be simplified as well. That's just 4/3. That could be my answer if I wanted an exact value. We'd be done. Again, this one wants us to plug into the calculator. Now, do I have to get to this point if it's asking me to round? No, we could have plugged it in back here from the very beginning. Again, I'm telling you all this because a lot of times these could still be on the part where it's asking you to leave your answer as an exact value. So you should be used to seeing it simplified as well. But plug into your calculator and see what you get. Yeah, I highly recommend using that high button on your calculator. We got 4 divided by 3 times pi equals, what you got? Anybody else type it in? You said it in? 4.18. Now, if we round it out to 2 decimal places, we really need to look at that third decimal because we got another 8. So we should round that up. So it's 4.1. I'm gonna round up to 4.19. You be careful because again, you need to look at that third decimal to make sure we're rounding it correctly. And again, it gave us units, so we should always include it. So that's in units. All right, question. When you did 4 divided by 3, did you hit equals? That's probably what you draw. So on your calculators, again, it'll do exactly what you tell it to do. But you have to make sure you type it in correctly because if you do 4 divided by 3 times pi on a calculator like this, you're doing 4 divided by 3. If you don't hit equals, it's not taking that answer, it's multiplying the 3 by pi once you hit times pi. Well, that's pi, right? Hit equals. And then you have to hit equals at the end. Again, the calculator will do only what you're telling it to do. So 4 divided by 3 equals times pi equals, and it should give you the right answer. The other thing that you could do, again, type the 4 over 3 in as a fraction on your calculator, then multiply by pi, but you still have to make sure you hit equals at the end. All right, go over to number 2, DEA. Well, now DEA, we're going from D around to E, all the way to A. This whole thing, we got the 120, plus we got 90, for a total of 210. So now our equation is 210 over 360 times, now they gave me diameter. Now I could divide it in half and plug into the same formula, but again, why do that when I have another circumference formula? This is diameter times pi. So we have 7 pi. Which part are you asking? This part here? The 210, we added those together, out of 360. And then multiply by our circumference, which since I gave some diameter, circumference with diameter is just diameter times pi, so 7 pi. So now, again, you could type that into your calculator right away. So like, let's say we did that right now. I could do 210 over 360 and then times that by pi. And it'll give me 1 point. I need more photos at 7. 12.83. Again, you don't have to show that work on these if it's saying round. For the purpose of the notes, I'm going to go ahead and simplify that. Again, I could drop the zeros off, so I got 21 and 36. That would give me divided by 3, that's 7 over 30. Sorry, 7 over 12. 7 times 7 is 49, so I can say 49 pi over 12. It doesn't matter if you put the pi on top or pi next to it. It's the same thing. But that would be a simplified version. That's your rounded answer. On B, oh sorry, not B, I'm in BC. On 3, we have BC. So looking at BC this time. Again, I'm going another color. So we're looking at that little piece. 35 degrees out of 360 equal, oops, times, let's see, 24. 24 for BE. What's BE? Is it a radius or diameter? Give me a diameter. So I could just say, all right, 24 pi. Because that's diameter. The diameter times pi is circumference. Again, helps you be familiar with some of the fractions for a circle. 45 out of 360 is exactly 1/8 of a circle. 1/8 times 24 pi. 1/8 of 24 is 3. 3 pi. So use my calculator and you get roughly 9.42. That one will change back and forth to the exact value for that. Any other question? All right. You want me to do one more? Are you guys ready for your assignment? Yeah, I'm gonna do one more. All right. Another color. Yes. All right. So CBA. Here we are. Okay, so this are here. All right, we have for CBA 45. This is 90. Add those together, we get a total of 135. All right, so 135. Man, are those ways? Yeah. Let me see the Super Bowl commercial yesterday. Unfortunately, I think we're still watching Super Bowl. Yeah, it's a scary commercial for the kids. You didn't see that? How many people watch the Super Bowl?
I won $30. I guess
Ladies commercial, it was like, it was very mild the whole time. It was two guys reminiscing about different things, and then all of a sudden, and then, oh, remember the time I bought my house? And then they walk into the house and there's like this zombie looking ghost that's horrific. And yeah, I wasn't expecting that. Yeah, go ahead. All right. Anyway, that threw me off when wasn't ready for that. Okay. So we got 135. That's this entire thing, 135 degrees for the green arc. Then we got 3 millimeters. That's for DO. What's DO represent? A radius. So we need to make sure we use a formula for circumference that uses radius. So 2 pi r. So 2 pi times 3. Now that one doesn't reduce as nicely. All right, that's 3/8. 2 and 3, that gives me 6. So we have 3 times 6 is 18. 18 divided by 8, that does reduce. Now again, you don't have to reduce this all the way right now. I'm doing this because you may have to write in exact values for something down the line. But again, if you want to, you could have plugged this calculator way back there. Either way, you should get the same answer. 9 divided by 4 times pi is 7.07. I haven't done that one today besides this class. I don't think so. Double check my answer. So, and that's in order. Okay, as far as the assignment goes, we got odds on page 13 and 14. That's your assignment. So instead of giving you the entire page of both of those, I just want you to do the odds on both of those. Yeah. It's like, I think 18 problems or something like that. But it's better than 40 problems. So it's up to you. Any questions? All right, again, all right, up here too, since this is being posted on Canvas. That's the sign, 13, 14 odds.